For number 33, we're going to write this series using summation notation. And so there are 5 terms. We're going to go from I equaling 1 all the way up to 5 for the 5 different terms. And just look at the numbers and identify the pattern. This first number on the bottom that's being multiplied just counts up by 1. 1, 2, 3, 4, 5. So it's going to be I, and it's multiplied by 1 more than itself. So it's multiplied by I plus 1. And on top, these numbers are 2 bigger than the term we're on. So the first term is I plus 2. 1 plus 2 is 3. 2 plus 2 is 4. 3 plus 2 is 5, and so on. So on top we have I plus 2. For 38, we're going to list all the possible rational zeros for this polynomial. So we're not going to actually prove whether they are zeros or not. You could test them by plugging them in and seeing if they equal 0 or not. But what we are going to do is create the list, and if there are any rational zeros, we know for sure that they will be somewhere on this list. We're going to have all the possibilities. And the rational zeros theorem is on page 328. So rational means a ratio. It can be written as a fraction, and the top number in the fraction is a factor of the constant term, which is 27. And the bottom number in the fraction is a factor of the leading coefficient, which is 3. And so just list all the factors of those two numbers. And here's the factors of 27, and here's the factors of 3. And then to create your list of all possibilities, make all the combinations you possibly can with one of these numbers on top and one of these numbers on bottom. And you don't need to repeat solutions. For example, 3 over 1 gives you 3, but 9 over 3 also gives you 3. So you're just going to write 3 in the list one time. And I don't have it listed here, but you should have plus or minus for all your possibilities, because the factors of 27 actually are plus or minus these numbers. You can get 27 by doing 1 times 27, but also by doing negative 1 times negative 27. So make all possible combinations and plus or minus, and that'll be your list of possible rational zeros. All right, for 39, you're going to need to use a graphing calculator. Write the coefficient matrix, so all the coefficients of our equations here, and I have it listed right here, the coefficient matrix. And depending on your calculator, you may be able to just enter these in and tell it to find the inverse, and it'll give you the inverse back. Or you might have to enter these as decimals and use a lot of decimals. I would suggest maybe even 9 to 10 decimals, so that when you round at the end, you can be accurate to 5 decimals. And if you don't know these decimals, you can look them up somewhere, but your calculator should be able to tell you. If you type in the pi symbol and then hit multiply, and I'll type it here, but like multiply by 1.0, for most calculators, when you multiply by a number that has a decimal in it, it gives you the result as a decimal. So if I did pi times this, or e times this, or square root of 2 times this, it'll likely give me the result as a decimal. Now if your calculator doesn't do that, there should be some button that will convert this to a decimal, so you can look right on your calculator what that decimal is. But yeah, hopefully your calculator lets you enter the matrix like this. Otherwise, convert it to decimals and put the decimals in. And then when you hit the inverse button, you should get something like this. Now, depending on how many decimals you typed in, your final numbers here might be a little different than mine. And I actually didn't type in that many decimals because I was trying to do this a little quick. So hopefully you have even more accuracy than I do, because I only have 5 decimals of accuracy. Hopefully you have a little more accuracy than this. And then what you do next is take that inverse matrix and multiply by our numbers here, the 2, 4, and 6. And when you do that multiplication, then that's how we solve these systems using matrices, it'll give us the solution of what x, y, and z are. And I have it down here, and again, because of rounding, these final digits may be a little bit off because I didn't type in, I typed my numbers in as decimals for these, and I only went to 5 decimal places. So again, that's why I was giving you the caution to enter more than 5 decimal places, because you can see, comparing to the answers, that I'm a little bit off here at the end, and that's because I only entered 5 decimal places at the beginning. So at the end, my 5 decimal places were a little bit off. And for these next two, solving the system graphically, you need to just graph these on your graphing calculator. For the first one, let me move it here. I've graphed them both. We got a circle, and then this blue line that intersects it twice, this blue curve. And this graph here actually tells me exactly what the points are, but you can estimate these pretty close by zooming in on your calculator or using the trace function. But you can also, with this multiple choice, it's pretty easy to rule out what the wrong answers are. We see this, this cross right here is a little bit less than 2 and has a positive y value pretty close to 2. So if we came in and looked at our choices, a little bit less than 2, well, B and C are more than 2, so they're out. So it's either D or A. And then a positive y value, oh, it has to be D. And we can verify that this one makes sense. A little bit more than -2 and a positive 1.5. A little bit more than -2, positive 1.57. All right. So yeah, with multiple choice, it should be easy to narrow it down just by looking at the signs, negative and positive. But on the graphing calculator, you also should be able to zoom in pretty close and get a good estimate. And that's what you're supposed to do on the next one. It's not multiple choice, but your graph will look something like this, and then zoom in pretty close and get a good estimate. In the final exam, I give partial credit. I mean, if you wrote 0.742 instead of 0.744, you're going to get full credit for the problem. So not even partial credit. If this is an estimate, you're going to get full credit if you're pretty close. And I can tell you drew the graphs and zoomed in and found a number that was gave a good estimate that's close to what the actual result is.